is the lab setup for the lab molecules in a sample of gas. You will be collecting data here virtually and then using that data to calculate how many molecules are in a sample of gas. What we will be using is a thermometer, 3 molar hydrochloric acid, a rubber stopper with a piece of copper holding some magnesium ribbon, and then we have a eudiometer that will be submerged in water to collect the gas underwater. The reaction that's going to be taking place is the hydrochloric acid with the magnesium to produce hydrogen gas. So we'll be collecting hydrogen gas and then calculating how many molecules are in that sample of gas. So what you're seeing right now is the eudiometer. 10 milliliters of the 3 molar hydrochloric acid is at the bottom. The rest of it has been filled with water, and then it's been capped off with the rubber stopper that's holding the magnesium ribbon. When I invert this and turn it over and submerge the rubber stopper underwater, that'll prevent the water from coming out, but also the hydrochloric acid is more dense. So it will actually migrate down when this has been flipped over, and it will begin to react with the magnesium ribbon. And you'll see that as bubbles. Those bubbles will then float to the top of the eudiometer and be collected. All right, the hydrochloric acid is now making its way down to the magnesium ribbon. You will see hydrogen gas being emitted when the two connect and the reaction begins. Another thing to point out is that the rubber stopper has a hole in it, so as the gas is collected and displaces the water can flow out into the beaker. Alright, if we speed this reaction up, the magnesium and the hydrochloric acid react. You can see all of the bubbles. Once the bubbles stop, we know the reaction has stopped, and we can look at the volume of gas that we've collected. Now that the magnesium and hydrochloric acid has completely reacted, we can see all of the water that has been displaced by the gas. Now we're going to ensure that the gas pressure inside the tube is the same as the atmospheric pressure outside of the tube. So we're going to put this into a 1,000 milliliter graduated cylinder with water, and we're going to move it down to where the two water levels are the same so that the pressure is equal, and then we will take our volume reading. All right, now I have lowered my eudiometer into the 1,000 milliliter graduated cylinder. And what that will do is that will ensure that the inside of the tube is the same pressure as the atmospheric pressure outside of the tube. Our eudiometers measure in milliliters, so you can see the water level right now. I'm going to lower it just a tiny bit further so that the two water levels are equal, and then we can take a measurement. Looking at the picture, what volume of hydrogen gas did we collect?